Welcome back, everyone. In this upcoming section, we are going to talk about networking. Networking is essentially how one computer or system communicates with another computer or system. Now, two models we're going to talk about is the OSI model and the TCP/IP model. But we're going to take a high-level overview of these models and really pick on the parts that are relevant for system design for us as web developers. The reason why this is so complicated is because networking is one of the most intensely deep topics that are out there inside of system design. It's actually an entire career path where you can work as a network engineer. And if you work at companies that are really successful in this communication and the speed of setting up the systems of these communications, such as Netflix, you actually make an enormous amount of money in the industry because it's kind of a niche topic if you go really deep with it. But for our purposes, because we're focused more specifically on the web development side of it, we're just going to do a high-level overview to understand what they are and then draw the relevant parts so that we can apply it into our understanding of designing systems. We're going to start with the OSI model. And OSI stands for Open System Interconnection. Now, this is really a logical and conceptual model that defines the network communication between a system in order to communicate with another system. It's a general model. So you can kind of see it as a bit of a universal model in that sense for just general computer networking. And it breaks up this communication into 7 abstract layers that are pretty much structured on top of each other. And because it is a general model for communication between two systems, I don't want you just completely mentally locked into this idea of how the internet works, but more just in general about any two systems overall in the world. As long as there are two computers that are communicating, you can use the OSI model to abstract out how that communication is happening. So let's go through these 7 models. You essentially have, starting from the top down, the application layer, the presentation layer, the session layer, transport layer, network layer, data link layer, and the physical layer. Now, it's important to note that each of these layers has their own protocols. When you think about protocols, they're really just a set of rules that defines how this data should be structured and then communicated. So these are going to be structured in terms of the syntax, which is how it's written, the semantics, which is like what key terms there are that are holding some kind of meaning, synchronization of how this communication is possible, such as like how much data gets transferred at a time, and then other things like error recovery. These are all rules that define the communication of data at a specific layer. To give you an example, the application layer, which is this top layer here, this layer holds things that are closest to the user. So as we mentioned, users start interacting with applications, hence why it's called the application layer. But the applications themselves don't live on this layer. Remember, it's the data that is being dictated, like the protocol, the rules that dictate how the applications might receive the data. So a less abstract example would be a user uses something like Google Chrome, which is a browser. The browser utilizes HTTP, which we all know, Hypertext Transfer Protocol. HTTP is the format that the browser understands. If it is actually going to render a website, it has to receive the data inside of this protocol format. Now, the next layer is the presentation layer. This layer is also typically known as the translation layer. So the data that we get from the application layer is extracted, and then it gets manipulated and formatted so that it is ready to be translated across the network. Now, the thing here is that what does that transformation look like? This might be encryption or decryption or compression as we know it, or translation. These are all things that we do when we need to actually get the files that we're getting in the HTTP format into the browser. If you think about it, sometimes we gzip them. That's a very common thing that we do in order to compress data down. That all happens in the presentation layer. Now, this session layer is the layer that's responsible for opening and closing the communication between two devices. As we know with sessions open and close, and there's a certain period of time in which that connection is alive. So the session layer is responsible for making sure that it stays long enough a session in order for all of the data to be properly transferred and then closed off so it's not wasting resources when that part is done. Now, the transport layer, which is the next layer, is the one responsible for end-to-end communication between two devices. So the session is responsible for opening that communication. The transport layer is actually the one that's responsible for making sure that the actual communication happens. So this includes taking data from that session layer that we were talking about and then splitting it into chunks and segments before sending it to the next layer underneath. This is also known as the network layer. Now, the network layer is essentially the one responsible for communication between inter and intra networks. So what is an inter and intra network? Well, when you think about a computer system, inside there are numerous communications that are happening between physical devices all on the same network. So what I mean by an intra-network is that if you think about LAN, that is a intra-network. So back in the 90s and 2000s when the internet was slower, if people wanted to play video games with each other at the same time, they would use LAN, which is a local area network, meaning that they're all on the same network and the devices communicate to each other on the same network. So again, the network layer facilitates communication between major groups of networks. So if there was, for example, two separate LANs and they had to communicate with each other, the network layer is handling that. The data link layer goes a layer deeper, and this one is actually facilitating communication between two devices on the same network. So if the network layer above was communication between two separate networks, data link layer is now the communication of devices on the same network. And then finally, the physical layer has to do with actually transferring bits of the data into a physical cable, hence how there is a physical cable here. So this is where data gets converted into a bit stream, which is essentially a string of ones and zeros. And this physical layer is important because devices on it must agree to the convention of what the ones and zeros are distinguishable from each other in a physical device. So again, there are different protocols here. Now, if this is confusing at all, do not worry. Honestly, the OSM model is one of the most standard things that get used inside of the industry of computers and software altogether. But it's not always the most relevant to us as web developers, but it's still very important because it really helps us with things like security and also things like understanding where different errors and fragility in the actual overall system of delivering a web application can happen. It's not the most important for you to know all of it by heart for system design, but it's important that you at least understand conceptually what's happening when people talk about these layers, because you're going to work with people who are network engineers. You're going to work with people that are vendors trying to sell you devices that help make it easier for you to do things at different layers. Because all these 7 layers exist when you're building some kind of web application business at scale. Now, you might offload the majority of this work and take things for granted because you kind of just plug things in, such as your computers, your servers, your routers. All this stuff is happening for you. But in order for you to understand where there is attacks that can happen into your system at a large enough scale, you'll need to understand how this model works. Now, there is extensive information about this because this has been around since the 1970s, 1980s. So there's a lot of data about this. I don't think you need to know all of this in super deep detail. Honestly, the way I explained it is relevant enough for the purposes of this course. But if you want to go deeper, you definitely easily can. And if you Google OSI and you just start looking through all of the different things that have been written about it, you will slowly piece together a better idea of this if you have not already. Again, for web developers like us, it's not as relevant. The one that's more relevant is going to be the next model, which is the TCP/IP model, and that's the one we're going to go into next. But again, I want to highlight this OSI model. It's just something that's helpful for you to frame your thinking around how these communications happen between systems. It's not something just happens simply. It's actually quite complicated. And I'm hoping that through this example of an abstract framework or a logical model that we see through the OSI, it just gives you a better idea of how you should approach understanding things like networking. So now that we have that, let's move on to TCP/IP.